All right. So what did I just say? Well, you told me. How many variables are there? Two variables, and therefore somewhere hidden in this mess there are two equations. Let's read the problem real quick. The length of a rectangular room, so a room much like this one, is 2 meters less than 3 times the width. Great, it's meters. So we're not in America anymore. We're somewhere else. So this room might be in Japan. Who knows? If its area is 96 square meters, and that's just a measure of area, right? You look on the floor, you see these tiles. Each one of these tiles is 12 inches by 12 inches. Well, it's 144 square inches, or 1 square foot. So meters squared is just a unit of measure. You're not going to square 96 at any point in this problem. Find its dimensions. So there's two unknowns. We have to find two equations. What are the two unknowns? The length, L, and the what? The width. Let's call that W. And then when I'm trying to write equations, I generally look for the verb to be in some kind of form. Yeah, is, right? Is, was, will be. As long as you know basic English or basic Spanish or basic, you can do word problems in almost any language. Because you just have to find eres or soy, or you know what I'm talking about. And that's where the equal sign is. So here's equal sign. Here's equal sign. Normally, that's not 100% accurate all the time, but generally if you find the is, you find the equal sign. So let's see. L, the length of a rectangular room is, L is what? 3W minus 2. Very good. And if you got that, that's awesome. All right. The second equation isn't so obvious. You actually have to pull from your toolbox of formulas. But it is in the second thing, and it does say area is 96. So let me just write A equals 96. But now I have three variables, so what the heck? I don't have to write m squared, because that's just the unit of measure. So it just tells me at the end of the problem, my length and my width has to agree with my unit of measure there, so everything is in meters. All right. But now I have three variables. I have an A, I have an L, I have a W. Hold on. Say that real loud. Area is length times width. So this formula is really LW is 96. What method of solving this system of equations are we going to use? Yeah, we aren't going to graph this. We're not going to do elimination because we don't even have similar types of equations, right? If you're going to do elimination, you have to be able to line up the L and the W column and the constant column and cancel something. You're going to do substitution here. And where are we going to substitute? Yeah, my length equation, 3W minus 2, is going to replace L here. So actually, let me do it on this side. L gets replaced with 3W minus 2. So 3W minus 2 times W will be 96. I'll just put a little arrow there. And that's by substitution. Well, there's no such thing as a 96 factor property, right? What there is a zero, or a zero product property, right? A ZPP. So I need to square or distribute this out. There's my W squared minus 2W. And right now it equals 96, but I know I can't solve a quadratic unless it equals what? 0. Normally. So, and that's the only technique I've taught you so far, right? So zero product property, we have to have it equal to 0, and we have to break this up into a product so that we can apply that property. So we're going to have to factor this. So if we're using AC method, what are we going to be looking for at this point? Well, actually, I skipped something, right? Wouldn't we first check to make sure that these are prime with each other, they have no factors in common? And they don't, because 3 goes into 96 but not into 2. 2 goes into 96 but not into 3. So we're good with moving forward on the AC. 3 times 96, 288. Dark! There we go. 288, but A is 3, C is negative 96, so it's actually negative 288. And we're looking for two factors of negative 288 that do what? That their sum is negative 2. All right, because B is negative 2. Now this is your moment to be strategic. If the two factors that we're looking for have a sum of negative 2 and their signs are opposite, right? What does that imply about them? There you go. They have to be close. Does that make sense? Because if their signs are opposite, you're actually subtracting them. And if the result is very small, it means the numbers are very close to each other. When are the numbers close to each other? When it's close to the square root of the number. So let me I'll pull out this calculator here because I think the screen will show up better. And let's look at what the square root of 288 is. You're not going to type the square root of negative 288 because you can't take the square root of a negative. But actually, sorry, I have to hit this first. And 12 square roots of 2. No, let me hit the standard to decimal button. So it's around 17. All right. I need two numbers that are around 17 that are 2 apart. That are 2 apart. 16 and 18. Let's see. 288 divided by 16 is 18. Awesome! You see the strategy led us right to the correct result. We're looking for two factors of negative 288 that have a sum of negative 2, and they are positive 16 and negative 18, or negative 16 and positive 18. Yeah, because we want the result to come out negative, and we want the sum to come out negative 2, so the bigger number has to be negative. Once you figure that out, the rest is just grouping, right? Rewriting the middle term as positive 16w minus 18w, and it doesn't matter if you put the 18 first or the 16, it'll still come out the same. Once it's there, let me zoom in here. I gotta find w. To find w, I gotta factor this and then set each factor equal to 0, right? Are there any common factors between these two terms? Just w. But if you had put the 18 first, you would have a 3, right? I didn't do that, so I'm going to go with what I have. I only have a w that I can take out. And when I do, what's left? 3w plus 16. All right. What can you take out of both of these? It's not obvious, right? It is 6. And let me talk about, again, this is where a little knowledge goes a long way. You know you want it to come out to a 3w. Because anytime you find the two factors, these things, when you're done grouping, will match, right? So what number would you have to divide negative 18w by to make it come out to 3w? Negative 6. And you can check that negative 18w divided by negative 6 is 3w. And you can also confirm that negative 96 is divisible by negative 6 16 times. So that's beautiful. See how anticipating what should be there kind of helps you set up what should be here. All right, so what matches times what's left equals 0. And what do you do with each of these factors? Set them equal to 0. This ought to be interesting. So this one tells me that w is 6 meters. This one tells me that 3w is negative 16. W is negative 16 thirds. Why am I saying Because it's negative. Not because it's a fraction. You can have a fractional unit of measure. That happens all the time, right? 5.5 feet. All right, but the problem here is a negative. You can't have a negative width. My answer is 6, not 6m, but 6 meters. Let me put meters here. This one is invalid. Sometimes we get invalid results when we're solving because we're using a mathematical model to represent a real-world relationship. The mathematical model will give us all the solutions to the equation we write. But some of those solutions don't make sense in real life. So we have to go, does this make sense? All right. Once we know W, what do we do with that to find L? Plug it back in up here. So if W was 6, then 3 times 6 minus 2 is what? It's 18 minus 2, which is, so I'm going to write equals 16 meters. And that is your solution. Does that make sense?